Hi everybody, welcome back to Modern Geometry. Let me just take a sip of my coffee. All right. So in the last lectures, what we talked about installing RStudio and as well as libraries, and those were just important for us to get set up so that now we can start looking and learning how to manipulate and transform data. So I think that a really good place to start is in data structures, and data structures can be a little bit abstract, and so I just want to bring forth a couple analogies before we get into the details. So the three types of data structures we're going to talk about, there are many, but the three types we're going to talk about today are going to be arrays. Another way that you can call an array is a vector. And we can see that with arrays and vectors that the data is stored in one dimension. So that means that you can have items, fill items in one direction, as many as you want. The second one we're going to talk about are data frames, which we have data stored in two directions. Looks very much like a spreadsheet, right? Where we have columns and we have rows. And then the other one we're going to talk about are lists. And so lists are a little bit more flexible in terms of what we can store. So let's talk a little bit about arrays first. And so for an array or a vector, I think I'm actually going to call it a vector just because it's shorter. In that you can have an item in at least two of the positions that are available, right? So this would be position one, this would be position two. If you only have one item, that's not considered a vector, that's considered an object. And so in many ways, an object is more simple than a vector, but an object isn't really a container, or it's not really a data structure. And so in this video, we're going to be talking about data structures. And so an object is just if you have one value. And that's not considered an array or a vector. As soon as you have two objects or more, it becomes an array or a vector. Let's just call it a vector. And so we have as many, we can store as many values as we want in one direction. Something important to note here is that the objects or the items which are in our vector have to be of the same type. So that means that they're either all going to be words, or they're all going to be numbers, or they're all going to be integers. But for example, we can't have a character here, a number here, a character here, an integer here. They all have to be the same type. All right, so that's vectors. Next thing we're going to talk about are data frames, and the rule about each of the items in one column have to be the same. So for example, we can have all this equaling numbers or integers, and all these being characters. So for example, this is going to be the name of the people in my family. So me, my brother, my sister, my dad, my mom, and this is our birthdays, right? So this can be characters, and then this can be a date, but we can't have name, date, name, date. Each column has to be of the same data type. And so that's something about a data frame. And in a data frame, right, we can store the data in two dimensions. So we can store it in rows, and we have in columns. The third type of data structure I want to talk about are lists. And so lists are more flexible in that lists are also only in one direction. And so maybe I don't want you to confuse you to appear that a list, I have two dimensions in which we have rows and columns. So just please ignore everything here except just this one column here. But lists are more flexible than data frames because each item that is stored within the compartment can be a different type. So remember when we talked about data frames, and here is that we can't store a number, a character, a number, a character. It has to be all numbers, all characters, all dates. With lists, we can put so for example, a date here, we can put a number here, and we can put perhaps a data frame here. So we can put a data frame in a list, and then we can put a character here, like a name. And so I just wanted to give this analogy because it can be a little bit abstract if I just show you the code. But with vectors, the data items are stored in one direction. They all have to be the same type. A data frame is essentially a multiple vectors or multiple arrays, right? So each one of these is going to be a different array, different vector, but it's stored together. And then the third one we want to talk about are lists. This is perhaps not the best example because it shows two-dimensional data, but really let's just think about this in one dimension here, and that we can store the items that we put in here can be different types. So we can put a character, we can put a date, we can put a data frame, we can put a character, we can put an integer. And so now let's look at the code and so to see if this makes a little more sense. All right, let's go to RStudio. So the first thing we want to talk about, like I was saying, the most simple type of data structure is going to be an object. So that is just one item to go into an object. So that's what's called my char object. Char stands for character. And so this is going to be a character. We use parentheses to indicate when the character string starts and when it ends. So let's run that. So we can see that in our environment here that our values are now going to equal there's one object here, and it's called my char object, and it has the item hello world. We can also do the same where we can create another object, but now it has an integer, and so we don't have to use these quotations because this is just a number. All right. So the next thing that we want to look at are our vectors, and like we said, remember we talked about the ice tray in which you can store items in one dimension that all have to be of the same type. And so we can see here that we put hello world and then hello universe. And so we're going to put that into my vector. And so we can see here that we have now the my vector is made, and it has two items. It has hello world and it has hello universe that are the same type. Let's look at some other functions that we can use here to be that are useful in sort of characterizing the different data structures that we have. So length is a function that we can use that we wrap our data structure, and it tells us how many items we have in it. And so we can see that there's two items in our vector because we put these are the two items that we're wrapping in it. Another thing that we can use is class, and so class tells us what type of items are in our data structure. So let's look at here, and we use class, and it says that it's a character, right? That there are characters, character strings within our data structure. All right. Next thing we're going to talk about are data frames. Remember I said that data frames are made out of multiple vectors put together. And so in each one of the locations that can hold values, that they have to be the same type. So we can put here, so we can see that this is how you create a data frame. You say create, you use data frame, and then in parentheses, this is going to be the name of the first column. So it's going to be letters, and then we're concatenating. We're putting all the different letters that we want to be put into it, and then this is going to be the numbers that we're going to put into it. So we have one column that are numbers, and then another one are letters. So let's see what happens. See, so there was an error, and the reason why there was an error is because we see here that there are 4 values in this vector or that are going to be a part of this data frame, and we can see that in this one here that there's only 3. So we can fix that by just adding a 4th one here. We put 4th, and then there should be no error. So now we can see that the data frame is now made, and it has the 2 different columns that we named with all the values that we have. Let's use that function that we talked about, class. So when we go here, so we can say class, and then we'll call our data frame my data frame, and then we want to look specifically at the column for letters. And so to find that specific column, we use the $, and then we can see it shows us all the different columns that we have in the data frame. So we'll use letter, and let's see. So it says that it's characters, right? Because we see here that we're using those quotations, and that is equaling. We're using the quotations, and that is it represents that this D is not an integer, but a character. And then again, we can go to numbers, and I believe it's going to say that they're integers. Well, it says that they're numeric. So if you don't specify these to be integers, it's going to just make them the type of item is going to be numeric. So they're numeric. So we can see here that we have two columns in the data frame, and that each one are they're different types. All right. So what do I have here? Okay, yeah, we can just skip this line. And so the next thing we want to talk about is going to be the list that I was telling you about. And so remember, we talked about lists in being kind of like a cabinet, in that we can put different types of items in one direction. And so we can see here that in the list we're going to put my character object, right, which just has the hello world. We're going to put my vector, which has those two values of hello world and hello universe, and we're going to put the data frame, right? So notice that it's a little bit different than we have here. With here, we're putting all the same type of items within one row, and then we're putting numbers in another row. But notice how here we're putting an object of a type of a class character, a vector that has two objects in it, and a data frame which has two columns and 4 rows. So, and we do that by using list. So when we record that, when we execute that, let's look at the list. So we can see here that the list is not going to present like the data frame, because it's not 2 dimensions, it's only 1 dimension. So we can see here that it says my list, right? That's what we made. The first item is just an object. It has character, hello, hello, hello world. The second item is a vector, because it has 2 objects, hello world, hello universe. The third object has a data frame. The third item in the list is a data frame, and the data frame has 4 rows and 2 columns, and that data frame is this here that we made before. So notice the difference between these different data structures. We had the array, or the vector, which has the same type of items in one direction, the data frame, which has the same type of item in each column in two directions, and then we had the very multi-purpose list, in which we can put different types of objects or different types of data structures in each of the locations that can store data. And so these are the 3 main type of data structures that I want to talk about. There is a 4th data structure, and they are very important, but not when just getting started with R. It's not really going to be something that you're going to use that often. But the 4th type of data frame, I just wanted to cover it for the sake of being thorough. And so our matrices. And so a matrix is essentially, it looks something like a data frame, but that what you're going to put in it are usually integers, or they're usually integers or numeric values, things with decimals. And so we can create a matrix by specifying the number of columns and then the number of rows. So when we do that, we can see here that a data structure was created in which there are 2 columns and there's 4 rows. But notice that we didn't tell the matrix what we want to put into it. We just said we want to create a data structure, and we can see that R filled in NAs in all of the locations where we can hold data, because we didn't tell it to populate it with anything. And so what we can do here to change that is we can tell it the matrix that now, instead of the first argument that we had here, and by the way, arguments are what we would specify within functions, and they're separated by a comma. And so we notice here that the argument that we're going to use here now is saying this is the data that we want to use. And so what this here is showing is we are populating 1 through 8. This just means 1 through 8. And so let's see what this is. So you see, it just gives us 8. It gives us 8 numbers, 8 integers, and from 1 through 8, And so that's going to be the data. And then in the same way, we are going to have 2 columns and 4 rows. And then by row means it's going to fill it like this. It's going to go 1, 2, 3, 4, 5, 6, 7, 8. And this would be in contrast. If this was false, it would fill the data like this: 1, 2, 3, 4, 5, 6, 7, 8. So let's execute this and see what we get. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8. And if we were to change this to false, let's see what we get. Yeah, so it fills it column-wise instead of row-wise. All right, guys, that's data structures, and I'll see you in the next one. Thanks for watching.